Hey guys, and welcome back to this video provided by Alabama Science in Motion on how to do the experiment we call cold specific heat. So this is a quick run through of our setup. I need one styrofoam cup that I'm going to use to make a cup of ice water. I need a sample of metal. In this case, I've got a copper sample. I've also got a string attached to it so I can use it to transfer it in the course of the lab. You need a couple of thermometers. Some people just use one thermometer, but I find two thermometers best. One to devote towards the ice water and one to devote towards the calorimeter. I'm actually going to use the Pasco wireless thermometers in the course of this lab. I've got a digital balance. I've got a calorimeter sitting over here. Calorimeter is nothing but another insulated device used for measuring temperature changes in. I've also got some room temperature water back here that's literally been setting out for a couple of days, and I can't stress it enough. If you're going to have a good data in this lab, you're going to have to use some water that's been left and adjusted to room temperature. Otherwise, the second you get your water out, it's going to start changing temperature as you're doing the lab. I've also got some ice I'm going to use. And so now at this point, what we want to do first is go ahead, and I have the students, and this is the first thing I have them do when they get in the lab. I have them just go in and start making, hey guys, make a cup of ice water. Do this very first thing in the lab. Make a cup of ice water. I'm going to even pack in a little bit extra ice. I'm talking ice water, and then I'm going to come back and I'm going to top it off with some water. Because literally, guys, I want a cup of ice water here. This is so important. And so now what I'm going to do is this. I've got my cup of ice water made, and I'm going to go ahead and I'm going to find a mass using my balance. I'm going to find the mass of the piece of metal I'm going to weigh. And as soon as I find the mass of that piece of metal, I'm going to go ahead and take that. I've got a pencil here. This is why the string is in it, so I can now place the piece of metal down. Ooh, I've got so much ice, I've got to jam it down in there. Well, hey, that's fine. Even better. And so I'm going to jam my piece of copper down into the ice water. And so now I've got this handy pencil attached so I can actually pull it out. So now what I want to do is this. I'm going to grab the calorimeter. I need to place some water inside of it. So I'm going to set the calorimeter on top of my balance. And now I'm going to hit the tare button. I'm going to zero it out. And so now I need to know exactly how much water goes into the calorimeter. Well, that's basically 100 milliliters, but I just said basically because this is the cool thing. By zeroing out the balance now, I can just read the balance, and this is also another big thing. If you want to make this lab come out right, how much water you use in here is so very important. If you use too much water, the temperature change is so small when you do this lab, you probably will get very poor results. You want just enough water to cover up the sample of metal that you're using. I also find this to be the best. When I move the piece of metal over eventually, I'll let the piece of metal lay over on its side, not stuck up in there. I'll let it fall on its side, and that helps me use less water as I do the lab. So now at this point, I'll look, and I've got 162 grams of water in here. So I'm going to cover that up, and now I'm going to do something. I'm actually getting ready to do the lab. I'm going to go ahead and turn on, this is a Pasco wireless thermometer. I'm going to stick it into the ice water, and that will let me monitor the temperature of the ice water. Now I'm also going to go over here, and now there's two holes in the top of these calorimeters. I'm going to turn on my other wireless thermometer, and I'm going to put it next to the hole on the outside edge. And what that'll let me do is this. I don't want to take this thermometer out of the water again. I want to, when I get ready to move the metal, I want to be able to just kind of pivot the lid open and then pivot the lid closed again. I don't want to actually do this in the course of the lab. This will definitely wreck your results. So I want this water, this thermometer, to stay in that room temperature water. So we've got one piece of metal in ice water. I've got a thermometer in it, monitoring it, and then I've got just some plain room temperature water inside my calorimeter, in my case about 162 grams, and I'm monitoring it with a thermometer as well. Now, after this metal has stayed long enough, and you may be wondering how long is long enough, it's just long enough. I like to keep it in here as long as I can. That way, when the students first come in, they can go ahead and get this cooling, and they'll probably be ready to actually do the experiment pretty quickly. But here's what you're going to do in the lab. You're going to have capstone on. I'll show you in a second what that data looks like. Have capstone on, mash record. That way you can be looking at the temperature of both of these two samples simultaneously. And then this is the big part of the lab. Move my balance out of the way. for the best results. So here we go. I'm going to pivot. Notice how I said pivot my lid out of the way, and I'm going to, as quickly as I can, I'm going to lift the sample of metal, taking no ice with me. I'm going to then, after I know this metal is cold, I'm going to remove it, and no water, no ice, slide it into, laying it down on its side. And now one last piece of advice. I'm going to give it the shaky shaky. And so what I'm trying to do is this. I'm trying to slosh it around so that the water, I'll say this, I don't want the metal sample touching the thermometer. I try and like slosh it in a way that I keep them off each other, and you'll see it in the data if that should happen. But what I'm trying to do is get this to thermal equilibrium inside there. So I want the metal, the thermometer, and the water to all be at the same temperature. And so after I've done that, then I should be good to go. All right, so let's move on and take a look at the portion of this lab where we actually get our data from Capstone. So hey guys, and welcome back to this portion where now we're going to take a look at the capstone part of actually getting our data in this lab. So you see I've got a display set up here. I've got a file called cold specific heat wireless open. You could also create one from scratch if you wanted to. All I've got is 2 temperature displays versus time. I'm going to go to hardware. I've got both of my thermometers turned on at this moment, and they are blinking. So there is number 791. I'll click and connect to probe 791, and there is my 085. So I'll then click it as well and get both those wireless thermometers connected to Capstone. And now I can see they are both connected, and they both have full batteries as well. So I'll click hardware and close it. Now remember, one of these is placed in ice water, so that I'll know the temperature of the metal. The other one is placed inside the calorimeter. The question I get from students is how do I know which one of these is in the ice water? Guys, it's simple. Hit the record button. Start taking some data. And as we start taking data, it should be pretty clear that this one is about 22 degrees, so it's obviously in the room temperature water, while this one is pretty close to 0, so this is obviously the one in the ice water. So I'm going to hit stop, and now I'll go ahead and tell you, I've actually had this metal soaking in that ice water with the temperature probe. At this point, I've had it sitting in there a solid 5 minutes, and that's me attempting to let that metal get to equilibrium. I will also say this, earlier in the lab, let me zoom in on that 0. I want you to look at something. Early in the lab, I said I wanted to make a cup of like icy ice water. Guys, this makes all the difference in the world. If you look, the temperature of my ice water is actually just above 0, less than 1 degrees. Believe it or not, this does make a difference in the lab. I'm trying to get that piece of metal as cold as I possibly can. So guys, I'm feeling pretty good about this. I'm going to hit record, and now I'm going to let it go for just a few seconds. I'm going to get some baseline data on this. So here's 6 seconds, 7 seconds. Again, I'm going to get a little bit of baseline data, and I'm going to start getting ready. I'm going to open the top of my calorimeter like you saw me do earlier. And again, pivoting. If you notice, you can't even tell that I've moved that thermometer. It stayed in water. And now for the hard part, to get the metal out of the ice water without bringing any ice with it. Got it up, out, dropping it in on its side. And now we start doing the portion of the lab where I'm going to do like a little swishing here. And so I'm beginning to swish the water, as it were, in that calorimeter. And so again, I want what I'm trying to do, and you can see it starting to fall on the display up here as well. You can see the temperature is starting to go down within inside of the calorimeter cup. And what I'm trying to do is bring this to some equilibrium. And these calorimeters hold their temperature very well. Boy, I'm feeling pretty good about this so far. I'm going to hit my little button here to blow it up, which looks terrible when I do that. But it really lets me see this plummet that's happened, because what I'm looking for in this top graph, I'm looking to kind of see that this temperature is reached equilibrium.
And guys, if you can tell, it looks like here we're probably 20 seconds in. I'm going to hit stop. I'm going to zoom this bottom data back out so it looks a little bit smoother than that. There, doesn't that look better now? And I'll even zoom this one out just a little bit as well. And so here's what we're going to do, guys. So I've got my data now for this run. So what I need to know is this. I need to know the temperature initial of the water up here before the metal came in. I need to know the final temperature. So when this thing bottomed out, when the temperature fell, I need to find this final temperature. Guys, the best way I know to do that, we got a couple of ways. You could use your multi-coordinate tool. So I'm going to click Add Multi-Coordinate Tool. And I could scroll and I could find like my last temperature, 21.8. Boy, that's not a lot of decimal places. I paid like $100 for this probe. Numerical format, vertical coordinates. Give me like 3 decimal places on that. There we go. 21. So I could actually just use this multi-coordinate tool. I could use it to get the temperature initial of the water. This would be the temperature initial of the metal right when it was removed from the ice. And then I could also use this, keep sliding over, and I could find this to find like the final temperature as well. Guys, that's a perfectly good way of finding your final and initial temperatures. One way I like to do though is this. I like to go up here, grab a highlighter. Instead of like finding a single point, I like looking at this little section of data right before the metal got added. And I like to take an average of that. So I'm going to select up here at the top, average. And it looks like I've got an average temperature of 21.86. So that tells me that my initial velocity before the piece of metal was moved into water was 21.87. And now I can also take this same box, keep moving over, and I can go out here somewhere to where it looked like things kind of planed off. And here we look at my average, and now look over here, my mean number, 20.867, which is about, oh, what? Wow, 1/100th different than my individual data point. So both these are acceptable ways. I just like doing this. I like getting a little bit more data in there. Let's also do this. I'm going to scroll back. I want to find right before the move. So this appears to be like right before the metal was moved. And let's do the same thing for this graph. Let's grab a highlighter. Let's move it down here. Let's highlight some data. Again, I think this just gives us the best data. And so now let's get an average here. So I'm going to hit my statistics button, and it's giving me an average of 0.1. I don't like that. I want more decimals. So I'm going to do something. I'm going to say, hey, move out here to the middle of the graph so I can see you better. And then I'm going to right click, tool properties, numerical format, and give me like 3 decimal places. 0.144. Yeah. So that's saying now I've got an average temperature, what looks like, of 0.144 degrees Celsius. So that's how cold that piece of metal was before it was transferred. And so they both end up the final temperature. So guys, here's how you can use Capstone. Don't delete your runs, because here's what's cool. Save your data. When you go to do your next run, hit record. And as quick as you can, guys, I'll say it again. As quick as you can, get your thermometers in your solutions, one in the ice, one in the water in the calorimeter. The longer it sits there, the better this data usually comes. Then make sure and leave the metal in there for at least like 5 minutes before you do this switch. So anyway, guys, hopefully this has you where you got your data, you're ready to go find the specific of these metals. All right, guys, thanks for watching our video. Bye.